Welcome to Code Report. I'm your host, Connor Hoekstra. Let's take a look at the contest that happened last week.
So last week we had a pretty quiet week with only two contests, Top Coder SRM 731 on Saturday at noon, and of course the weekly Leak Code Contest 76 on Saturday evening. Taking a look at the top 10 leaderboards, for Top Coder SRM 731, the most notable finish was B. Mary taking third place in Division 1, and for Leak Code Contest 76, we had Lim Panda currently ranked 22nd, finishing third, and we also had 24th ranked WYH9346 finishing 7th. And while I was gone on vacation last week, we also had Code Forces round 470, which resulted in some interesting changes in the overall top 10. You can see that second ranked was finishing in the contest was Umnik, and finishing ninth was Yui, but Tourist, who was previously the number one ranked individual on Code Forces, finished 147th, and that dropped him to overall to fourth place. So now Petra is in first place, Umnik taking second, and it'll be interesting to see how quickly Tourist is able to get back to that number one spot. So the problems that we're going to be covering this week are problem 1 from Leak Code Contest 76 and problem 1 from Top Coder SRM 71 Division 2. And I'll be covering 2 other problems from the Leak Code Contest later in the week. So let's take a look at our first problem. Our first problem we'll be covering is problem 1 from Leak Code Contest 76 entitled Similar RGB Color. The problem states, in the following, every capital letter represents some hexadecimal digit from 0 to F. The red, green, blue color, hashtag AABBCC, can be written as hashtag ABC in shorthand. For example, hashtag 15C is shorthand for the color hashtag 1155cc. Now say the similarity between two colors ABCDEF and UVWXYZ is AB minus UV squared minus CD minus WX squared and minus EF minus YZ squared. Given the color ABCDEF, return a 7-character color that is most similar to ABCDEF and has a shorthand. That is, it can be represented as some hashtag XYZ. Note that for each color, it's a string of length 7. A color is a valid RGB color for I greater than 0. Color I is a hexadecimal digit from 0 to F. And the last two aren't too big a deal, other than that all of the inputs and outputs should be lowercase. So let's take a look at some examples and see if we can understand this a bit more. So the example they give us in the problem is that our input color is 09F166, and the answer that we output should be 11EE66. And the explanation for that is that the closest, the most similar color that we can get to 09F166 is this, and it shows that by having the following. So 09 minus X11 squared, and then F1 minus EE squared, and 66 minus 66 squared. So what that's going to give us is if we convert these hexadecimal numbers into base 10, we'll end up with 8 squared plus 3 squared plus 0 squared. And so the first thing we'll note is that the squares don't really matter. We can just take the absolute value, and the question asks for minus signs, but I'm using addition. It doesn't really matter. If you use minus, you're trying to maximize the number, but I think it's easier if you think about it, trying to minimize the number using additions. So get rid of the squares and you have the same thing, 8 plus 3 plus 0 equals 11. So you're basically just trying to minimize this number, and you're trying to construct a color that uses the same character for each of the first two, the second two, and the last two characters. And so the way we're going to think about this basically is that for each of these two characters, we have to compare it with the first digit of the 2-digit hexadecimal number. So when we're comparing, trying to find the hexadecimal 2-digit number that is going to result in a difference that's the least amount between the current one and some same digit hexadecimal number, it's either going to be this digit twice, one less than this digit twice, or one more than this digit twice. So because 0 is the first digit, we can't go any lower than that. So this one's going to be not applicable. So the same is just looking at 0 twice, and then one more is looking at 1 twice. For F, the one before it is E, the same one is F, and 1 greater than it doesn't exist. And for 6, we have 5, 6, and 7. So basically, we just need to calculate the values, the base 10 values for each of these guys, and then calculate the base 10 values for each of these comparisons, and then figure out which one has the smallest difference. And if we do that, we're going to find that 1, E, and 6 have the smallest difference. So this is basically a brute force problem where we're going to check every single combination, and we're just going to choose the ones that minimize this value at the end of the day. So let's take a look at the code. So let's start at the bottom here with our function similar RGB, which takes a string C, so that's sort of our input, and then we're just going to return this hashtag plus the 2 characters. So this find min function, it passes in each of the characters individually, so 1, 2, 3, 4, 5, 6, and then this function is going to output the character or digit that minimizes the difference. So if we come up to find min, we're taking in 2 characters, and the first thing we're going to do is we are going to construct or initialize a map. And our map up here, as you can see, the key is a character and the value is an integer, and all it's going to do is it's going to map the all the hexadecimal digits to their value. So 0 is going to be 0, 1 is going to be 1, and then when we get it to A, that's going to be 10, B is going to be 11, and so you can see we're looping from 0 to 9, and then 0 to 5 inclusive, and we're adding 10 to the 0 to 5 ones. And this way we're going to end up with a quick way that we can look up what's the value of our hexadecimal digit. And then using that, we can, by passing in 2 characters, get val. That's basically getting the base 10 value. And the way we're doing that is, if you know about how to sort of calculate a base 10 value from base 2, it's the same thing, but for base 16, you just have 16 values. So because we're only having 2 digits, we're multiplying B by 1, because 16 to 0 is 1, and then A here, or X, by 16. So we just return this, and that'll get us our base 10 value. And so we come down here, we set up our value of our current 2 characters by passing them in, and then we initialize this difference equal to 256, because we know that's going to be the maximum difference between two digit hexadecimal numbers. And then we initialize our string S, which is what we're going to return at the end of the day. And all we're going to do now is that for each character or digit in our map, we're going to loop through, calculate the absolute difference between our value, which we just calculated, and the value of a double digit, so same digit hexadecimal number, and we'll keep track of this in difference. So if our current temporary difference is less than our calculated difference before, we just reset diff, and then we set S equal to this character. And then once we finish this loop, we are going to come out and return S plus S, and that'll get us our answer. So note that in the previous problem, or in the visual explanation, I showed that we only needed to check the one before, the current one, and the one after of our current, first digit in our 2-digit hexadecimal number. But that requires a lot more code. That's actually what I did during the competition. Is I implemented, I got an iterator pointing to our current first digit in our number, so A, and then I used the previous and next functions. But that requires you to write a ton more code, and it doesn't simplify the complexity. It does run a little bit faster, but for the sake of trying to code things as fast as possible, you should just try and do something like this. And note that here, where we're doing int t, calculating our temporary difference, if we had C++17, which Codeforces does, but LeetCode doesn't support yet, we could have used something called if statement with initialization. So that's where you can basically fold this line into our if statement and use a semicolon. And what that does is just reduce the scope of your variable t. And it would have saved us one line. So that's just an interesting fact that some of you might find interesting. And last but not least, the time complexity of this is going to be constant because whatever our input is, it doesn't impact the runtime of this. The second problem that we'll be covering is problem 1 from Topcoder SRM 731 from Division 2 entitled Ring Flex. So the problem states, Hero has an infinite periodic string t. You are given the s that is the period for Hero string. For example, if s equals abc, Hero's actual string is t, abc, 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 and so on. Let n be the length of string s. Hero is now going to use the infinite string to generate a new n character string by doing the following steps. 1. He will choose an offset, a non-negative integer x. 2. He will choose the length of a step, a prime number p that is less than n. And 3. The new string will consist of the first n characters we can read in the string t if we start at the index x and after each character we move p positions to the right. Find and return the lexicographically smallest string Hero can produce. And note that the string we're going to be given is at most going to be 50 characters, and every character is going to be between lowercase a and z. So let's take a look at some examples to inform how we're going to solve this problem. And note that lexicographically just means the order in which you'd find it in a dictionary. So here we have 4 examples that were provided to us by Topcoder. Our input strings are in our first column, the answers in the second, and the start index and the prime number that you're going to use to jump from character to character are shown in the third and fourth column. So we're going to very quickly walk through how we get the answers. So you can see here that this is the lexicographically smallest string we can generate using the rules that were defined in the problem. So for our first example, CBA, we're going to obviously start at A, which is our lowest, our smallest character, in value. And then from there, we have to choose a prime number that we're going to sort of jump from character to character. And if we go past, we're just going to sort of loop around to the beginning. So we're going to end up choosing a prime number 2, so that's going to jump 2 spaces ahead, which will end up at B, and then from there it's going to jump to C. So you end up with ABC. If we move to the next problem, sort of the same thing, but here A is in the first position, so we're going to start at index 0, and then we jump to B, which is going to be a prime number of 2, and then once again you go to C. So these, although have different input strings, have the same answer. And for the third example, we're going to start at A and then jump 2. So we'll get another A, another A, another A. Then this is going to wrap around to the B, C, and B, which is what we end up with. And last but not least, we're going to start at the fourth index. And note that you might initially think that if you start at the first or the 0th index, you can then set your prime number that you're going to jump to 4, but 4 is not a prime number, so you can't use it. So the next best thing we have is starting at the 4th index and then choosing our prime number that we're jumping to be 2. So we start at A, then we go to B, we wrap around to A, Z, A, B, A, and then Z. And so once again, the way that we're going to solve this problem is just by brute force. So let's take a look at the code for that. So here we have a function getMin that takes string t as a parameter, so that's our input string. We set local n to be the size of that string, and then we initialize our result s, which is also a string, to be length n, and we're going to set it initially just to be all z. So this constructor is similar to the vector constructor, where the first parameter is the size of your string, and the second parameter is the default value for each of the elements of it. So here we have on the next line a vector of integers, which are the primes. You could write a piece of code to sort of check whether a number is prime. or to generate this, but I think it's faster because there's only a few of these to type out, and it's pretty easy to walk from 0 to 50 and just type those out. And then we come down to the main part of our function. So we're going to loop through every starting index, that's 0 to n minus 1 inclusive. And then we're going to loop through all our primes. And then we have this little if statement to make sure that, in case n is less than 50, we have to break out of this loop and finish our function at that point. Or finish our loop at that point. And then we declare a local string temp, and then we are going to loop from j to n, so because we want our string to be size j, and we want our temporary string to be size n, and then we do a plus equal of each of the characters that we move to. So the way we're going to do that is we start at I, and then we're always getting prime times j, and in case this goes above what our n is, we have to go modulus n. So by completing this loop, we're going to create a string starting at I and jumping prime, the value of our prime. And after we do that, we just need to check, is this less than s? And if so, set it equal to s. If not, keep your current s. And if we complete this, we're going to end up with the correct answer. So not the most efficient code. The time complexity of this is it's O to n to the 3, which is cubic. Note that you might think it's quadratic because primes is fixed, and that's actually not the case though, because we have a limit saying that n is not going to be greater than 50, but if we did increase n, we would also have to increase the size of our vector of primes. So yes, time complexity of this problem is going to be cubic. Taking a look at the contests that are happening next week, we have once again a pretty light week, although I think Codeforces is probably going to announce another round later in the week, so once again follow me on Twitter for updates about that. But announced currently, we have Codeforces Educational 40 happening at 2 p.m. on Thursday, and of course the weekly LeetCode contest, Contest 77, happening on Saturday evening. And last but not least, we have the top 10 viewing countries. So a little bit of movement over the last 2 weeks since I had one of these episodes. United Kingdom and Russia swapped spots in 5th and 6th. Netherlands jumped 2 to 7th, and Ireland and Romania dropped down 1 spot each. And we have a newcomer this week, which is Norway, who is sitting in 10th place. So once again, thanks to everybody who's watching all around the world.
As always, if you enjoyed this video, hit that like button. Make sure to follow me on Twitter for reminders 30 minutes before contests start. You can find all of the code that I use in my videos on my GitHub page. All of the links are in the description down below. And finally, if you want to make sure you don't miss any of my upcoming videos, make sure to hit that subscribe button. Thanks for watching, and I'll see you in the next video.